Hello, my gorgeous friends of Webflow. It's your friendly neighborhood Francesco from Superside here. Today, we're talking about something that seems simple at first, but has probably confused every single Webflow user at some point. The mysterious world of the position property. What's the difference between static, relative, absolute, fixed, and sticky? When should you use one over the other? And how the heck do offsets, stacking, and parent containers play into all of this? Well, today we're going to answer all of that. We'll explore every positioning option in Webflow, one by one, using super clear examples that you can try yourself. No long-winded theory, no assumptions, just practical insights to help you finally master how elements behave on the page. And I promise, by the end of this video, not only will you understand positioning, you'll be able to use it to your advantage, create cleaner layouts and fix alignment issues before they even become problems. So, if you're looking forward to it as much as I am, stick around, and if you find my videos helpful and want to support my work, hit the like button and subscribe to my channel. But now, if you're ready, let's dive in. Let's start with the most underrated of them all, position static. Now, don't worry, I'm not going to throw at you some overly technical definition here. Static simply means, leave me alone, I'm part of the normal page flow. In other words, elements with position static are exactly where they're supposed to be. They don't float, they don't stick, they don't overlap other stuff, they just follow the natural document flow, one block after the other. And guess what? This is the default value for most elements in Webflow, like our div block right here. If we take a look at the style panel under the position section, you'll find the position property. And unless you've changed it, Webflow will show you this little static label right there, because it's, again, what most elements are set to by default. Now, in this case, our div has a class called card, which we're using just to give it a bit of padding, a defined width, an aspect ratio set to portrait so we can clearly see it, and of course, a background color so it stands out. Then, on top of that, I added a combo class called static, which, spoiler alert, does absolutely nothing. It's just there to label what we're looking at. And here's something interesting. Even if an element is static, you can still visually move it around the page without changing the layout by using move transforms. For example, you can apply a move transform on the X or Y axis. It shifts the layout visually, but the other elements on the page still behave like it never moved. This is especially useful for creating subtle animations or tweaks the spacing without breaking the layout. One small note, if you use percentage values in your transform, they'll be relative to the element's own size, not the parent's or the page. So yeah, that's all you really need to know about static. It's the do nothing, stay where you are setting. And sometimes that's exactly what you need. Alright, the next value in our CSS positioning lineup is relative. Let's take a look at what we're working with here. We've got a card wrapper, which is just a div block set to display flex with a gap of 2 REMs, a bit of padding on all sides, and a background color to help it stand out. Inside this wrapper, we've placed two cards side by side. Both of them share the same base class, so same width, padding, and aspect ratio. The only difference is that each one has a different combo class, 1 and 2. And more importantly, both cards also have a combo class called relative, which simply sets the position property to relative. Now, here's the thing. When you switch an element's position from static to relative, nothing seems to happen. Visually, it behaves exactly the same. And that's just because, just like static, relative keeps the element in the normal document flow. So, what's the point? Well, when you use relative, you unlock the ability to apply offsets: top, right, bottom, and left. These offsets let you shift the element from its original position without affecting the layout around it. So, if we move card 1 using left equals 4 REMs, for example, it slides over to the right, but the other elements don't react. They still behave like it's in the same place. This kind of shift is visual only, and it's useful when you need to make small layout tweaks without disrupting the structure of the page. Quick note about percentages. When you use percentage values for offsets like top or left with position relative, they're calculated based on the size of the parent element. But be careful, if the parent doesn't have a defined height, or if the layout uses flex or grid, the percentage might not behave as expected. So, always double check how it renders, or consider using moving transforms instead. Now, let's talk about something else that relative enables: z-index. Here's our setup. Card 1, which appears first in the navigator, has a z-index of 0. Card 2, added right after, is using the default value auto. Now watch what happens when we move card 1 so that it overlaps card 2. Card 2 shows up on top, and that's totally normal, because without any special stacking instructions, elements that come later in the HTML naturally render on top of those that come before. Even though card 1 has a z-index of 0, that doesn't give it any visual priority. It simply establishes that it can participate in stacking, but at a base level. But the moment we change card 1's z-index to 1, it now appears above card 2, even though it still comes earlier in the structure. And that's the real power of combining position relative with z-index. You can control the stacking order of elements, regardless of how they are arranged in the DOM or the HTML structure of the page. Before we wrap up this section, let me show you a common practical use case. We've got another card here, this time with no combo classes. Inside, we've added a simple paragraph with the class card text, just for margin and text color, and a card badge, which is just a small div block with a fixed size and a background color, so we can see it clearly. By default, the badge sits right before the text, exactly where you'd expect. But now, we apply our relative combo class to it, and set top to -2 REMs and left to -2 REMs. Boom, now the badge floats up and to the left, as if it were pinned to the corner of the card. This is a super common pattern in Webflow. You might use it for a new label, a discount tag, or a visual marker that decorates your card. But this use case, while handy, isn't the main reason we care about relative. The real reason will become clear in the next section, when we introduce the absolute position. Now it's time to talk about one of the most powerful but also misunderstood positioning values: absolute. Let's take a look at the setup first. We've got a card, and yes, it has our trusty combo class relative applied to it. We'll see why that matters in just a second. Inside the card, we have two elements: a paragraph with the class card text and a small div block with the class card badge. Right now, the badge has no combo class, which means its position is still static. That's the default value, as we've already seen. But watch what happens when I apply the combo class absolute to it. This class simply changes the position property from static to absolute. As soon as I do that, the paragraph above shifts upward. It's like the badge vanished, at least as far as the layout is concerned. And that's exactly what's happening. When you set an element's position to absolute, it's removed from the layout. The other elements behave as if it's not even there. They reclaim the space it used to occupy, based on the structure of the page. And, just like with relative, assigning position absolute unlocks the offset properties, top, right, bottom and left, as well as z-index. Now, let's spend a moment on z-index because it really matters when we're working with overlapping elements. Here's the thing. Once you take an element out of the normal flow, like we're doing with absolute, it's no longer bound by the usual stacking rules. That means if multiple elements are stacked in the same spot, Webflow has to decide which one goes on top. And that's where z-index comes in. The higher the value, the higher the stacking priority. So, an element with z-index 10 will appear above one with z-index 5. And if z-index isn't explicitly set, the browser will fall back to the order in the DOM, or the HTML structure of the page, which doesn't always give you the result you're looking for. So, anytime you're using absolute, and especially when you're layering things like badges, tooltips or buttons that sit on top of images or cards, it's good practice to check your z-index values. Now, here's something interesting I want to highlight. If we set an element to absolute, but don't touch the offsets, you'll notice that it still appears more or less in the same visual spot it had before. It's no longer affecting the layout, but it hasn't moved elsewhere either. That only happens once we actually start applying offset values, like top 0 and left 0. As soon as we do that, the badge jumps to the top left corner of the card. So the obvious question is, why does it go to the corner of the card? The answer might seem simple. Well, the card is the parent of the badge, so it makes sense. But that's not quite right. When you use absolute positioning, the element looks for a reference point. Specifically, the first ancestor element that has a position set to anything other than static. In our case, the card is acting as the reference, but only because we gave it position relative earlier. Let's remove the relative class from the card. Now its position is back to static. The badge? It's gone. Well, not really. It just moved. Now it's aligned to the top left corner of its new reference, the first ancestor with a non-static position. In this case, that's no longer the card. It's the section that wraps everything. So, if we scroll all the way up until the top left corner of the section enters the viewport, that it is, our badge sitting patiently in the new top left. That's how absolute positioning works. It needs a reference, and that reference is the first ancestor with relative, absolute, sticky or fixed positioning. If no such ancestor exists, it defaults to the body element. And just a quick note about offset values, especially if you're using percentages. Unlike transform-based movement, when you set left 50% or top 20%, for example, on an absolutely positioned element, those percentages are always relative to the size of the containing block, meaning the reference element we just talked about. So, if the reference has a width of 400 pixels, then left 50% will move the element 200 pixels from its left edge. This gives you a lot of flexibility, but also makes it important to know exactly what you're positioning against. So, what can we use this for? Well, there are lots of use cases for absolute. Too many to cover here, honestly. And I'm thinking of doing a video entirely dedicated to that. But just to give you a quick idea, let's say you have a hero section and you want to position an image that acts like a background element. You don't want it to affect the layout, you just want it to sit in a corner, no matter what's going on around it. So you could give the section position relative, Set the image to position absolute and choose something like bottom left from the Webflow positioning controls. That way, the image is anchored exactly where you want it and doesn't mess with the rest of the layout. So that's absolute. Out of the flow, anchored to a positioned ancestor, super useful, but with great power comes great responsibility. Now let's move on to position fixed. The layout is basically the same as before. We have our card, this time with no relative combo class, and inside it we've got our usual card text paragraph and the card badge div block. Right now both elements are using the default position static, but let's apply the combo class fixed to the badge, a class we created just to set its position to fixed. And boom! Just like that, the badge disappears. Now, technically, of course, it hasn't disappeared. It's still there, but it's no longer part of the layout. Just like absolute, using position fixed removes the element from the normal document flow. So other elements shift and rearrange as if it were never there. But in this case, since we haven't defined any offsets, the badge is just floating somewhere off screen. That's because when you apply position fixed, you unlock the same properties we saw before, offsets like top, right, bottom and left, plus the ability to use Z-index, but until you define those offsets, the browser doesn't know where to place it, so it just sits in a default spot that usually places it outside the visible area. Now, let's apply a top offset of 0 and a right offset of 0. As you can see, the badge jumps to the top right corner of the viewport. Not the card, the viewport. And here's one of the key differences between absolute and fixed. With absolute, the element positions itself relative to the first ancestor with a non-static position. But with fixed, it always positions itself relative to the viewport, regardless of its ancestors. Even if we give the card a position relative, the badge stays fixed to the viewport. It doesn't care about the parent anymore. This is super important to understand. No matter what, fixed positioning anchors the element to the visible screen area. And just like with absolute, offsets like top, right, bottom and left define where the element will be placed. If you use percentage values, they are relative to the viewport size, not to the size of the element or its parent container. So for example, top 50% will place the top edge of the fixed element at halfway point of the viewport height, and left 25% will place it a quarter of the way across the viewport width. Now, let's scroll down the page for a second. You'll notice something strange. The badge disappears again. This time the issue isn't about the badge's Z-index, but rather about the Z-index of the sections that come after. In our layout, each section has a position relative and a Z-index of 1. That means these sections create their own stacking contexts, and they now sit on top of the badge, even though the badge is fixed. Even if we assign a Z-index of 1 or even 10 to the badge itself, it will still appear underneath those sections, because its stacking context is tied to the section it's originally placed in. So the only way to make it visible again is to increase the Z-index of that parent section, so that the badge, as part of that stacking context, appears above everything else. For example, we can give this section a combo class that sets its Z-index to 2. That way, the badge, anchored to the viewport but still logically part of this section's stacking context, remains visible even as we scroll past other sections. This technique is especially useful when building fixed UI elements like floating buttons, badges or scroll indicators. Now let's take a look at a more common example. one you've probably seen 100 times, the fixed navbar. In this case, we've given our navbar a position fixed, top offset of 1 rem, a left offset of 1 rem, and a width of calc 100% minus 2 rems. So why the left offset? Because we want the navbar to span the full viewport width minus 2 rems for horizontal padding. By setting the width to calc 100% minus 2 rems and the left offset to 1 rem, we center it visually, leaving 1 rem of spacing on both the left and right sides. This creates a nicely balanced layout that feels visually aligned, while keeping the navbar fixed to the top of the page at all times. By the way, this particular navbar also includes a gloss effect, and if you're curious about how that was built, there's a full tutorial linked in the description down below. Alright, now it's time to talk about one of the trickiest ones: position sticky. Once again, we're working with the exact same layout, a simple card with some text and a badge inside. No combo classes applied yet, so everything is still set to static. Let's start by selecting the badge and applying our sticky combo class, which, as you might expect, is just a shortcut we've created to change the position property. But nothing seems to happen. Even if we scroll the page, absolutely nothing changes. That's because, just like with relative, absolute, and fixed, we unlock the offset properties: top, bottom, left, right, and the z-index. But until we actually define one of those offsets, sticky behaves almost exactly like relative. Now, let's remove the generic sticky class and instead apply the combo class sticky top, which sets the position to sticky and the top offset to 0. And here's where the magic happens. As we scroll, nothing changes until the top edge of the badge reaches the top edge of the viewport. At that point, the badge sticks to the top of the screen and starts behaving just like a fixed element. It stays there even as the rest of the content keeps scrolling, until its parent container ends. At that moment, the badge stops being sticky and returns to its normal flow. If we scroll back up, the behavior is the same in reverse. As soon as its top touches the top of the viewport again, it sticks, until it's back in its original position. This is the core behavior of sticky. It's like a hybrid between relative and fixed. It flows normally until a certain scroll position is reached, and then it becomes locked to the viewport. And just like we did for the other types, let's clarify. What do the offset values refer to? In this case, they're calculated relative to the scrollable container, which is usually the viewport, unless you've defined a different scrollable ancestor. So, if you use percentage values, they'll be calculated relative to the size of that same scrollable container. Let's move on to another case. This time, we apply a different combo class to the badge: sticky bottom, which sets the position to sticky and the bottom offset to 0. Now, as we scroll the page down, nothing really changes. But if we scroll up, trying to go back to the top, once the bottom edge of the badge hits the bottom edge of the viewport, the badge locks in place there. It stays anchored to the bottom of the screen until its parent container ends, and then it goes back to flowing normally. It's a fun little flip of the behavior we saw earlier. And there's another important point here. The amount of space where the badge can move is also affected by the padding applied to the parent card. So, if the card has extra padding on the top or bottom, that space will also affect when and where the badge can stick. Now, let's explore a third and more creative use case. This one's a bit more unusual, but it really shows how versatile sticky can be. We start with the same card layout, but this time the card has a combo class called Overflow Auto, which, as you can guess, sets the overflow property to auto. Inside the card, we have a div called card inner content. This element has a width of 200%. This setup, combined with the overflow property, makes the card horizontally scrollable. Now, inside this inner content div, we place the usual text content. And then, outside of it, but still inside the card, we place the badge. At first, if we scroll the content horizontally, the badge scrolls out of view, just like any other static element. But if we apply the sticky left combo class to the badge, which sets the position to sticky and the left offset to 0, we see a completely different behavior. Now, as we scroll horizontally, the badge stays anchored to the left side of the card. And this is important. In this case, it's not the viewport that determines when the badge becomes sticky. Instead, it's the scrollable container itself, the card, that defines when and how the sticky behavior is triggered. This is exactly what makes sticky so unique. It adapts to the scrolling behavior of its nearest scrollable ancestor. Before we move on to the bonus section, I want to pause here and emphasize something important. The behavior of sticky can break, and it usually does, if any ancestor of the sticky element has an overflow property other than visible or clip. So, if your sticky element isn't behaving as expected, check its parent containers. Even if the sticky element itself is perfectly set up, it won't work if any of its ancestors, especially the immediate parent, has overflow, auto, scroll, or hidden. But why? Because sticky positioning relies on being able to measure space inside a visible flow. If that flow is cut or isolated by an overflow rule, it loses its reference and fails to stick. And that wraps this section. We'll take a quick look at some practical use cases in the bonus section, but I'll also say this. Position sticky really deserves a video of its own. There's just so much you can do with it, and so many edge cases worth exploring. Let's wrap things up with a little bonus section. Just a taste of what we could explore in a full video entirely dedicated to position sticky. Because honestly, this property deserves it. We'll look at 3 real-world use cases that show just how powerful and versatile sticky positioning can be. We're starting with a layout that might look familiar if you've watched my table of contents tutorial, link in description. It's a simple 2-column grid. We've got a wrapper div called grid, which uses, surprise surprise, CSS grid. It's set up with 2 columns, 1 row and a 2 rem gap. Nothing fancy. Inside the first column, we've dropped a TOC component, again just a placeholder for now, and in the second column, we've added some body text to simulate a long blog post. The idea is simple. As we scroll through the content on the right, we want the TOC, table of contents, on the left to stay in view. Sounds like a job for position sticky, right? So that's exactly what we did. We applied sticky positioning to the TOC with a top offset of 150 pixels. But it doesn't work. Why? Because the grid wrapper has the default alignment of stretch on both axes. This causes the TOC to fill the entire vertical space of the grid, which means there's no room for it to move or stick. To fix this, we simply change the vertical alignment of the grid to top. Now the TOC only takes up as much height as it needs, freeing up the space it needs to actually become sticky. And voila! As soon as the TOC hits that 150 pixels offset from the top of the viewport, it locks into place. It stays there while we scroll until the bottom of its parent container, the grid, is reached. Then it unsticks and scrolls away. Classic sticky behavior made possible by one small but crucial alignment tweak. Now let's switch gears and look at a horizontally scrollable layout. We've got a wrapper called Flex, which, as you can guess, uses Flexbox. We've set its display to flex, added a 2rem gap between items, and made sure the container spans 100% of its parent section. We've also set overflow auto because inside this flex wrapper, we've got 3 columns, each of which takes up 40% of the parent width. That adds up to more than 100%, which triggers horizontal overflow. Each column is also a vertical flexbox layout, filled with simple paragraph elements. To prevent these columns from shrinking or growing and messing with our layout, we set the flex sizing to don't shrink or grow. This ensures that each column respects its 40% width and overflows as expected. And now for the cool part. We want the first column, maybe it contains labels or row headers, to stay visible while the rest of the content scrolls. So we apply a sticky class to that column, which sets its position to sticky and its left offset to 0. And just like that, as we scroll horizontally, the first column stays perfectly locked in place on the left side of the container. Everything else moves, but our sticky column remains visible, making the whole table easier to read and navigate. For our final example, let's talk about one of my favorite sticky effects, the revealing footer. You've probably seen this before. The footer is always anchored at the bottom of the page, but as soon as you scroll past the final content section, the footer starts to appear, as if it's being revealed gradually. This is incredibly easy to do in Webflow. All we need to do is set the position of the footer to sticky and the bottom offset to 0. That's it. No interactions, no complex wrappers, no code, just a single property. The result? A smooth, elegant effect that feels way more advanced than it actually is. And that's a wrap for this section. There's so much more we could explore about sticky, so if you're into this kind of thing, stay tuned because I'm planning an entire video with deep dives and even more use cases. But for now, let's move on to the final wrap up. Alright, we covered a lot of ground in this video, so let's quickly recap the key concepts. We looked at how position relative doesn't actually move the element out of the normal flow, but simply offsets it visually. We explored how absolute and fixed positioning take elements out of the layout entirely, but rely on different reference points when it comes to offset values. We saw how sticky offers the best of both worlds, flowing naturally in the layout until it sticks, and how it's affected by overflow. We also covered how offsets are calculated, especially when using percentage values, and how to troubleshoot common issues when things don't behave as expected. Finally, we wrap things up with a few bonus examples to show just how versatile sticky positioning can be, from pinned table of contents to horizontally scrollable layouts and sticky footers that gracefully appear as you scroll. And if you found this helpful, don't forget to like, subscribe and hit that notification bell for more Webflow tips and tricks. Thanks for watching and I'll see you in the next one. Matane!